right, next up we got a guy who's not analog, he is digital, although his last name might fool you. This is Jay Calanog. He's going to be talking about First Impressions Last in the Astronomy Research Seminar. Let's welcome Jay, please.
Good morning, everyone. So my name is Jay Calanog. I'm the new guy in physics and astronomy. And I'm really, really excited to be here today to share the work that I was involved in this past fall and now also currently working on in the spring, which is the Astronomy Research Seminar. So as much as I'd love to take credit for this seminar all by myself, I just can't because it really wouldn't be possible without the help of these people. So I'd like to just take a moment and just acknowledge them for their contributions. I'd like to thank Brady and Pat Boyce. They're a father and son combo who pretty much reached out to me and talked me into implementing the seminar into Miramar College. They pretty much provide all of the external resources that our students need in order to do this project. I'd like to also thank Russ Janae. He's basically the pioneer of this seminar, and he was the first person to successfully make this a course in their own, in Cuesta, in San Luis Obispo. And of course, I would definitely have to thank my department chair, Gino Loquillo, and Fred Garces, my dean, because they've just shown nothing but support and have been advocates about expanding this program and also making it completely sustainable. And of course, this would not be possible without the support of our students. I need students for this project. I can't do this by myself. Some of them are here today, and hopefully they have good things to say about the seminar and my talk. So a little bit of motivation of why I did this in the first place. So I was one of those few people that already figured out what I wanted to do before I even started college. I wanted to study physics from the very beginning. And I stuck with that path the whole way. So, being the hardworking students I am, I took all the classes, the labs, the lectures, and I got really, really good grades. Of course, I worked hard. And then, when I got into grad school, I was faced with my first real independent project. And I realized that I really had no idea what I was doing. I couldn't coherently put together all of those skills and the knowledge that I learned from all these lectures and classes that I took and apply that here independently in the setting. It was a very, very steep learning curve. And so just to summarize that experience, in order for me to do research, I had to learn how to do research. So eventually I got through it, or else I wouldn't be here with you guys today. And so when this opportunity presented itself, it was just so natural for me to think about my own personal experience and how I could help our students. And so the goal is to go from here to at least here. To have some sort of idea what they're doing. So they know what they're getting themselves into. To reduce the risk of student failure and increase the probability of student success. And so the analogy that I like to make is comparing this to sports, and specifically basketball. So whether you're a person who's curious about playing basketball, or you want to pursue it professionally, what do? You don't take a bunch of classes on the theories of basketball strategies. You don't take a bunch of labs and workshops on learning how to dribble, learning how to shoot slam dunk. What do? You play the sport as soon as possible, because only by playing the sport can you actually figure out how all of these skills tie together in the overall big picture. And so if we can do this and apply this concept in the context of sports, why can't we do this for our students who are either curious or serious about pursuing a career in science? And so that's the whole reason. So just to give you guys a brief overview of the seminar, it really is a unique opportunity for students to get involved and started in professional scientific research. And the disclaimer is that it is focused on astronomy, but I would argue that whatever skills they learn here is very, very applicable to any kind of chemistry they're get into or curious about. And so the main objective of this seminar is to impart is not to impart knowledge. And so they're not going to spend a lot of time learning new physics, learning new astronomy. Instead, we're more focused on giving them experience, and how the whole process works. And we want to be able to attract people from all walks of life, different backgrounds. And so we don't have any prerequisites. And they don't have any, they don't need to have any prior experience with this. In fact, we welcome that. And the primary goal for this whole seminar is to get themselves published in a peer-reviewed research paper, in a peer-reviewed journal. So when students do this, they really, really appreciate what scientists have to go through. Fortunately, we now live in a day where we don't even know what a peer-reviewed journal is, what peer work is. What does that mean exactly? And of course, the secondary, but also very, very important goal is to give students a great first impression. When they get their feet wet and get themselves involved, what it means to be a scientist. And so here's a typical semester timeline of what students have to go through for the seminar. And I really just want to focus on basically the first 2 weeks, which is, that's when they're learning material on their own. It's self-paced learning, but while they're doing that, they're also brainstorming what they want to do, what they want to study. And then while they're doing that, they're going to also start drafting a proposal. The next 8 or 7 weeks is basically spent writing and analyzing the data that they acquire. While they're doing that, they're also thinking about how they're going to present their findings, their results, to a group of people, to their peers. And then, hopefully by week 16, they'll be ready to present their results and also have a draft ready for submission. So really, the most time-consuming part is the peer review process because their progress depends on the comments and the feedback they get from other people, which can sometimes take a little bit of time. So just to give you guys a glimpse of what students do, this is pretty much an example of a video lecture. Here's Grady giving a lecture on double stars. So the primary focus of what they study are these objects in the sky, double stars, and just to give you guys a little bit of background information. Basically, they're stars that you just see are very, very close in the sky. And you might be more familiar with a more technical term, binary stars. So what's the difference? Double stars, you don't know if they're binary, meaning they're physically associated, orbiting around each other, or are they aligned by chance, meaning you're seeing them like this in the sky, however, are they really like this, or are they actually close together? Okay. That's actually one of the goals of the seminar, to figure out the difference. Here's a proposal that the students wrote. One of the perks of being in astronomy, and people in astronomy would also say that you're not a real astronomer unless you get to make a really cool acronym. And so students here learn why they're studying what they're studying, how they're going to do it, how they're going to complete it, and how much time they're going to need for this project. All of this is going to be presented in front of a panel, and they're going to decide whether they're going to be most likely funded or they're going to be rejected. If they get rejected, of course, you have to rewrite a new draft. This is an example of the iTelescope network, which is pretty much the network of telescopes that are robotic and automated that students have to apply for time. And so these telescopes are scattered all over the world, mainly in the US, Spain, and Australia. I really wish that we have funding to actually fly our students there, but fortunately for us, it's all automated. So the process of learning how to use a telescope, it's pretty much streamlined. They don't have to. They just have to submit whatever they're going to observe. Once they get their data, they have to analyze it. And here are 2 pictures of the double stars that they studied for the 2 student teams that we had this last fall. But one of the main goals is to pretty much imagine where they are in the sky and where they are relative to each other. What they do is they pretty much compare this in the context of historical data. Other people like William Herschel, for example, a very famous astronomer, and let's figure out, are these 2 stars actually orbiting around each other, or do they exhibit some kind of random pattern over time? And here are the two drafts that we submitted and now have been accepted for publication this past January in the Journal of Levels for Observations. So here are two abstracts, and this is a result of maybe 10, 15, 20 revisions. Imagine about 5 or 10 people giving comments on every essay that you submit. That's what they feel. So it's a lot of fine-tuning on their part, and they stuck with it. They got published for it. Here's a picture that was taken on January 28th when they presented this in a local library in front of professors, college students, high school students, middle school students. You can also see Snapchat Professor Daphne Figueroa making our students feel a little bit nervous. But there were questions in this kind of setting. They didn't just present their findings, it wasn't show and tell. They actually had to answer and stand up there. Tough questions. Okay, so what does this do for our students? For our students, it gives them a chance to develop. So over the course of the seminar, they're going to have tangible and intangible milestones, which all eventually lead to their professional and their personal growth. And so the tangibles you can see here, they get to develop a research proposal, present their findings, get published in a journal. These are all stuff that you can put on your resume and really just make them stand out. But intangibles, for example, I told you guys before, this is a very long and tough process. And so as they're going through this, they're developing the determination, the persistence, the mental toughness, and the grit to go through something very, very challenging. And that gives them a really big sense of pride and accomplishment. They have to be able to handle the responsibility of working in collaboration. One of the things that's different about doing this seminar and taking a lab class in science is that things work a little differently when it comes to. And so if you're taking a lab class as a student, you're basically working for your professor. In the seminar, you're working with your advisor or working with your professor. And in return, I'm working with them as well. And so I really have to hammer it down to them that everyone's reputation is on the line, including mine. Another thing that's different about the culture when you're working in a seminar like this is that the students are actually gaining exposure to the rules and the politics of science. So what's an example of a rule of science when you're doing it professionally? This is something that's not very intuitive to our students. When you're doing research professionally, not everyone is actually expected to put in an equal amount of work. And it just comes out naturally. And the reason for that is because you have people that have different specializations in different things. Some people know how to write, some people know how to read, some people know how to analyze data really well. And you really can't expect them to put in the same amount of work as everyone else. So it just comes out naturally. So you have to get over it. Politics. You guys just saw those papers, right? And there were like 6 or 7 authors in those papers. Who gets to be first author? That's the question, right? Because in the field of science, there's this subliminal thought that happens in our heads that, the first author pretty much does about 70% or 90% of the work. So they really have to professionally address that internally within their own student teams. They get to participate in the community of practice. So while they're doing this, they're not just contacting me for help all the time. They're contacting other experts, other professors, other teams. And so they get to share and they give their ideas. And they're also using this as a chance, as a networking event, or a networking opportunity. While they're going through the peer review process, sometimes a very harsh critic comes along and says, I don't like your paper. I think your paper sucks. And that's really, really insensitive sometimes. But as an advisor, as a mentor, I have to really teach them how to address that professionally. And it just really does happen sometimes. While they're presenting, I told you guys before, they're getting grilled up there. And so I make them do practice presentations. And where I assume basically a devil's advocate, I'm just grilling them all the time. Because they have to be prepared how to justify their methods and their conclusions. And what they have to realize at the very end is that this is good for them, because their ideas are being valued. They're introducing new methods, and they're introducing their conclusions, and they have to be able to justify them. What else does it do? So, after completion, many of our students are stuck in this cycle. I can't get a job because I don't have experience. I don't have experience, so I can't get a job. One of my hopes for this seminar is to break this cycle. How? Well, because it introduces new opportunities for them. So it gives them writing points, for example, when they apply for internships. And it just increases their eligibility even more. I mean, let's admit it. How many undergrads do you know have a published research paper under their belt? So here's an example of a UC San Diego STARS program. That's their personal statement problem. And so when students have to answer questions like this, what experiences have you contributed toward preparation, and what are your research interests? I find it very, very tough to answer if I were to put myself in their shoes and all I did was take classes. It's very, very hard to talk about. You have to make up something. We all know they do. Okay, on my end, because I'm involved in this too, right? How many of you guys have ever felt like this? We're all instructors out here. How many of you guys have felt like this when students send you an email and they talk about how they sat in your class, they loved your class, they got an A in it, and they ask you for a lot of recommendation. And you're here thinking, that was like 2 years ago. What was your name again? I have no idea who you are, right? I mean, I'll be honest, I feel like that. And so, for me, working directly with these students, I can confidently write these letters. I can naturally just write these letters. Right? And it allows me to write strong, genuine, and compelling letters of recommendation. And I recommend them without any reservation. I can vouch for them. So here's an example of another research program, this time offered by UC Irvine. It's their Inspire program. And I'm supposed to talk about how motivated and how committed the student is, the strength and weaknesses of that student, and their ability to adapt for any situation. I mean, again, imagine a student taking your class, they got an A in it. Can you talk about all of these confidently? You can't. I can, at least. And so, again, this just naturally comes out for me when I'm working directly with students. What about for transfer? So, some private universities actually hold students in a higher regard if they do something for an honors contract. And the honors contract is actually one of the options students can do when they participate in the Astronomy Research Seminar. And so what do they say? Here's a quote from the Regional Admissions Council of California. So what they find after interviewing a bunch of students is that for the most part, they have nothing that they can speak passionately about, even though they look amazing on paper. Right? But if you're part of an honors program, it just kind of comes with a package that they're going to be required to present in a class or some other setting, and they know how to answer questions. And I can tell you this much. If you're part of the seminar, you're presenting every single week. You have deliverables every single week, and you're answering questions. So they're going to be more than prepared to answer the questions that transfer admissions have to ask. And they're definitely passionate about what they do. All right. So my goal for the seminar was to help students succeed. Turns out, what a coincidence. That's also Miramar College's goal. So it makes sense that it actually aligns with our integrated planning framework. So two of the things I want to highlight was a marketing and outreach plan, and also the culture and ethnic diversity plan. So for example, we have already stated that we're transitioning from a culture of inquiry to a culture of action. So let's just show that. So if you look at the strategic planning assessment scorecard, which is SPA, or staff, it's basically a SPA in a cruise ship. We've identified that we have not reached our benchmark for outreach activities and programs. So the number 152 here is basically the number of outreach activities that we're trying to reach. Right now, we're 94% of that. And so we came up with a plan to address that. We're supposed to identify curricular and co-curricular activities that celebrate diversity. How do we do that? Let's ask. Jets News, October 2016. With the help of Stephen Quiz, he highlighted our students when they presented and they won first and second place among all the other colleges and among all the other high schools that presented for their proposal. So what does that mean for them? Out of all the proposals that they saw, they were the ones that were most likely to get funded. Goal number 4 for diversity. We're going to offer and promote programs that attract students from underrepresented groups for specific fields. So in STEM, specifically, what does that include? That group. And so I can tell you that for this spring, out of 8 students, this is the diversity that we're looking at. And so I don't want you guys to think that I'm kind of fulfilling some kind of quota. That was not my intent in the first place. Okay? I had no idea that I was going to get 6 women, for example. But I can tell you what this means for me. I'm really excited to work for them. And I cannot wait. I'm really looking forward to the work they're going to be producing at the end of the school. So at this point, I'd like to just leave this slide with my summary on what the Astronomy Research Seminar does for our students. But I would like to end on this note. So we've all heard the phrase that experience is the best teacher. Right now, our students are currently at the stage of their lives where they're exploring different possibilities for their careers. And so, as faculty, as administrators, as staff, let's guide them on that journey. Let's nurture that curiosity that they have, and let's connect them to these experiences. Thank you. So at this point, I'd actually like to just invite a couple of my students from the fall semester, and they're just going to give a little bit of testimonial of what they went through this past fall. It'll be short.
So my name is Kelvin. I'm a second-year student at Miramar, and I was the first author of one of the papers that were accepted for publication. And I just want to start by saying this is the most involving thing I've ever done in college. The opportunity to do real scientific research is rare in college, and especially to be published and recognized for your work. And over the past couple months, I applied for several internships, scholarships, and most importantly, the UC transfer application. And this has done so much for me. Like the personal statements, I always want to mention this because this makes me stand out. Dr. Calanog was able to write several letters of recommendation for me for all these programs, and that definitely gives me an advantage to get in. And I kind of see this as like a domino. This is like one of the first dominoes. So when one domino goes, the other ones will also fall. So this gives me an advantage to get into other programs and advance further into my education and my career.
My name is Parth, and I was also a leader in one of the teams. It was listed as PWAC, which stands for Parth, Will, Alex, and Kyle. And yeah, same as what Kevin said, like it opened so many opportunities for me to get into different colleges, hopefully go to different research programs, and hopefully like in the future I can at least use this as a stepping stone for further research that I do in my career. And yeah.
My name's Alexander. I'm actually a Mesa College student. One of my professors, my astronomy professor from spring 2016, recommended that I get in contact with the seminar to see how it might spark my curiosity for academic research and moving forward professionally. I started by taking my Astronomy 101 class just to kind of get it out of the way as an I get see, and towards the end of the semester, it was something that turned out to be a little bit of a passion for me. And coming into my fall semester, meeting up with Jay, Parth being actually my principal investigator on the paper that we did, it was a wonderful experience, and it was something that was not only a motivation for me academically, but professionally to seek out other opportunities to see what I can do, because now I just have to get these classes out of the way so I can move forward and do something in the field of choice of astronomy that I'm looking at. Currently, I'm working on the second semester of the seminar out of Mesa, helping out with my professor Arena. And we have 3 groups right now of 4. We're going to be meeting up at noon to go over what stars are going to be looking at. And we're basically using the same format that Jay helped us set up. And that's one of the things that I'm grateful for, is he kind of helped us get in mind that we're going to keep going on a schedule. We've got things to do, and then kind of let the students do their own thing and check back in on them. And as a student advisor for the Mesa team, I'm really enjoying that experience, and I look forward to working with some of the leaders from the project, because some other institutions that I'm interested in actually proposing to have finally gotten some funding, and that would be a wonderful experience, even if it's not accepted, to actually write a formal proposal for an institution like Chara up at Mount Wilson. And I'd like to thank Jay for the time he spent with us and helping us with the headaches of going over all the grammar and edits and input on our paper. So thank you.
Thank you guys. Alex, don't give too many secrets away to Mason. All right, well, thank you guys. Thank you.
Wow, I think I'm going to be saying wow a lot today. Amazing stuff.